Now, say we want to get some wind or movement on our tree. First we're going to do is we're going to create a skeleton, a JZT skeleton node. And we're going to get the final level of our tree just here. And we're going to plug that in. And it's going to take a second to process. While it's processing, I'll explain what this is doing. So this is transforming the skeleton that we generate from the modeling stages into a KineFX friendly skeleton, which is able to do deformations just like any normal rig. This can be kind of slowed with some of the Houdini tools. I'm hoping to improve this in the future. Okay, cool, done. So now we get this, and we can see it is just a normal skeleton. This is actually a KineFX skeleton. We can see it's generated all the friendly KineFX attributes as well. So following that, we now need to create a root. We need to tell it what is the root of this tree. Let's create a group node. I'm going to call this root group. Set it to points, and I'm just going to use the bounding region just quickly, and that's fine. I know exactly that it's just there. Maybe make it a little larger. Let's get the next one. Sweet. Now following, I'm going to create a JZTree wind node and plug it in, and I'm going to flag it. Starting off, yeah, we can already see it's working. Look at that, wind already pre-applied to our tree. I want a little bit less directionality, just want a little bit of nice turbulence maybe. Go down here, I'm going to change the speed to 0.6, and I'm going to reduce the strength to 0.8. Fantastic. Now the next step is we need to kind of bring this all together and deform together. So what we're going to do is we're going to create a JZT skinning node. You need to tell it what is this capture frame. So looking at our wind, we can see that the wind here starts on frame 1. So I'm actually just going to set this to frame 5 just for now. And the first thing I want to do is I need to plug in the geometry. So I'm going to grab this part up here from when we initially modeled our tree, just here, and plug it into the geometry level just there. Next we need to tell it all, it says leaves, but it's really all in any instances of packed geometry you want to deform with it, and I'll plug that into just our merge just there. Now finally we need to tell it what animated skeleton do we want this to deform to. So let's grab this and let's just set this to our JZ wind, sorry. Now I'll flag it and let's give it a second just to process. It's generating a bunch of procedural skin weights and then reskinning it back to the skeleton that we've got. Great. Now if I set this forward, we can see that the whole tree, including our star up the top, is all moving perfectly. And it's all pretty quick. I'm hoping to improve the speed of this as time goes on, but for now this is all okay. Great, okay. I should show you the last little things here. So, this red node is really just a preview tab so you can see where things go, but obviously when you're rendering and shading things, you don't want to be, playing with packed primitives and normal geometry just at the same time. So, I created these extra output nodes here. So you can output just the geometry here, which is just the stuff we modeled from up here, just deforming, and then another one for the leaves. I should also show that the leaves do actually work with the wind, so I'm going to go back to my leaf instancer and turn on the wind enabled. Now when I turn this on, it does slow down a bit. It's not real-time playback, but it's pretty fast. Again, over time I'm planning to improve the speed of how all this works. Cool. So now with that turned on, if I change the frame, we should be able to see... Oh, there's the other, sorry, I forgot to do this. On the JZT skinning tab, you need to tick on the leaves have wind. So I'll tick that on now. It'll recompute. And there we go. All working a treat. Leaves are moving, all the stuff's attached, and we are able to shade.